Assalamualaikum and hello. Now I'm going to focus how to determine the product form when alcohol undergoes dehydration process in preparing alkene. We can use two examples in this video, which are example 6 and example 7. Now, I'm going to start this question by using the tips here where step number 1, you are going to expand the structure, and this is where you have to determine the carbon chains involved. And the next one, you are going to identify the OH group. For the step 3, you are going to eliminate H2O. So how? You are going to pick OH and hydrogen from adjacent carbon. And once you got the alkene as your product, you have to label the major and minor product by using the Sayzeff's rule that you've learned in the previous video. Now, let's continue with this example 6. I got my starting material, which is alcohol. So this is going to be my reactant where I'm going to expand the carbon chain. So this is going to be my parent. So I got 4 carbon here. So this is going to be carbon 1, 2, 3, and 4. The next one, carbon 1 attached to OH group and H. Carbon 2 attached to H and CH3. Carbon 3 attached to H, and carbon 4, H3. So I just expand the part where the carbon atoms involved, which are carbon 1 and carbon 2, because carbon 1 you got the functional group, where this is the step 2, you have to identify the functional group here, which is hydroxyl, and hydroxyl is at carbon number 1. And next one, you have to identify the hydrogen from adjacent carbon. So the adjacent carbon is carbon 2, where you got CH3 and hydrogen. So we are going to take out or eliminate this H atom altogether with OH group. So when answering the question, you have to write in the specific form, which is in chemical equation. So I'm going to write down my answer as chemical equation. So the dehydration process, we will undergo concentrated sulfuric acid. So I'm going to use concentrated H2SO4. And you also got heat, the triangle symbol. And from here, we are going to eliminate OH and H by making them as water. So I already highlighted for you OH and H. Both of these are going to be adjacent to one another. You cannot take OH and H at the same carbon. That is totally wrong because you cannot form the double bond by using one carbon. So that's why we have to take out H and OH from adjacent carbon. Then our product can be double bond here between carbon number 1 and number 2. So I'm going to write it down, my product H3C, H2 bonded to C double bond C, CH3, and I got H2. So this is going to be my product plus H2O. And from here, you can determine and label this one as major product because you can only form one product. And H2O is what we call as byproduct or side product. So this is how dehydration of alcohol reaction by using elimination when you preparing the alkene. Let's continue with example 7. I'm going to use the same tips as before. First, I'm going to expand the carbon that involved in this reaction. The question asks you to show the products. So now I'm going to continue with example 7 where it asks you to show the products formed in this reaction for dehydration of 2-butanol, and you have to name those products. So please take note my numbering. So I'm going to start my numbering from here 1, 2, 3 and 4. So I got 4 carbon atoms in my parent chain. So as usual, if I want to start answering this question, I'm going to write it down in chemical equation. So I will copy back this structure. So I got my structure like this one. This is going to be carbon number 1, number 2, number 3 and number 4. And as you see here, 2-butanol means that OH group at carbon number 2. Next, I expand hydrogen at carbon number 1 and hydrogen at carbon number 3. So this alcohol, 2-butanol, will undergo dehydration process by using concentrated H2SO4 with heat. So right now, I'm going to determine and predict the products formed in this reaction, where we are going to take out OH minus and H plus. So these two are going to combine together, making as H2O. So OH is from carbon 2. So this one I'm going to take out from here. And now H I'm going to take from adjacent carbon. So as you see from here, adjacent carbon to this carbon is carbon number 1 and carbon number 3. And both of these carbons got hydrogen atoms. So it means that we are going to show two different products. So I'm going to choose from carbon number 1 first. From carbon number 1, I'm going to take one hydrogen from here, making the double bond between carbon number 1 and number 2. So I'm going to draw my products, which is H2C double bond C. We got hydrogen left here and CH2 CH3. So this is my product. The first one, A. Next one, I got my second product where I taking out OH from carbon number 2 but hydrogen from carbon number 3. This one, making the double bond between carbon number 2 and number 3. So I got another product which is CH3 bonded to CH double bond CH CH3. And then this is B. And I got my byproduct which is H2O. So this is my equation for example 7. And I cannot put my H2O at the same one line because I don't have enough space here. So if you got enough space, please make sure you put the equation in one long sentence, in one line. So now we are going to determine between these two products, A and B, which one is going to be our major product. I'm going to apply Sayzeff's rule where we are going to focus between carbon-carbon double bond. So for A, we got this one, and for B, we got this one. If I give the numbering, you can see that this is the numbering for the carbon chain. So, if you want to take a look for the Sayzeff rule, we are going to calculate how many alkyl groups attached to carbon-carbon double bond. So you can see that at structure A, you got only one alkyl group, which is this one. And then for structure B, you got two alkyl groups, which are CH3 and another CH3 that attach to carbon-carbon double bond. So which one is going to be our major product? The major product is structure B. So I'm going to label this structure as major product. And this one, A, as minor product. And last question, the question asks you to give the name for those products. So for A, we are going to determine the name for A with 4 carbon chains, and you got the double bond at carbon number 1. So the name for A is 1-butene, or you can write it down as but-1-ene. Next one, for B, the name for B, you got double bond between carbon number 2 and 3, but still the parent chain is 4 carbons, so the name will be 2-butene, or you can write it down as but-2-ene. So these are the answers for example 7. I hope you can understand how to show the products form, which is our alkene, by using dehydration of alcohol. That's all for this video. I'm going to see you in the next one. Thanks for watching. Bye!